All right, I think we're ready to get started. I put the link for the video and the code on the class as well as in the Slack channel. So if you can see the tonight class, the link is in there. It's also in the Slack channel if you want to see the video again later. I have the code linked inside the Slack channel, not Slack channel, inside tonight's assignment area. If you want to go and look at the code, the only code we'll really see tonight is a little bit of not fully finished code, because I want to show you the definitions of many-to-many relationships and how you would achieve that. So the first two things for tonight, one, I hope the studios are going well. Most of all, I hope everyone is caught up or catching up on the assignments. It's not actually the case that everyone is caught up, but if you could get there, that would be swell. If everybody could get all those assignments done so that you can get through to the graduation and then ideally onto employment via an apprenticeship. Speaking of which, if you have a project you've been working on and would like to show it in any capacity, let me know, or let your teaching fellow know, and then we will let Catherine know, because she wants to, ideally, if people are willing to show some of what they've been working on from a project standpoint for the pre-apprenticeship, she'd like to show off some of those projects if possible. Although if you don't want to show your project off, totally fine. But let your teaching fellow or me know if you would like to do that. And if you have questions about your project or what to do, I'm happy to attempt to answer those. I can do my best. The feedback I'm going to be able to give is mostly technical though, not necessarily exactly what Launch Code is looking for. I can ask Catherine, you could also ask her, she has a printout that says very specifically what is looked for in each type of project. I believe she sent that out once already. But if you would like that, Catherine has it. You can get it from her. But I'm happy to help out from an idea and implementation standpoint on any project you're wanting to do, as are your teaching fellows.
I brought sheets and tape. So I was thinking.
Oh man, comes prepared. I would vote the middle one first. And then we can just put a sheet over the screen and no one has to see it. Oh. But, well, if someone wants to do starter questions, I can help you do that. Just stand in the windowsill. I'm thinking ahead. If you could put it on not the window and like the side panel, that would probably be best. The tape. Otherwise, it's difficult to clean that off of a window and then. You can just stand there and hold the sheet the whole time. Or someone else can do the lecture and I'll just hold the sheet up.
I just have an example of who I can see.
Yeah.
You brought multiple. Can people see this at all? Because I can't. But as long as you can see it, that's fine. I can just guess at what's on there. Oh. Teaching fellows, I'm sorry, I forgot to commit my questions when I wrote them on Friday. And I didn't push them out till 10 minutes ago. But there are, in fact, questions. Is anyone that's feeling really excited about covering them?
Excited about what?
Well, between Tom, Mary, and Jonathan, does anybody want to cover the starter questions?
Are we doing the poll tonight?
I think Johnson liked this.
Oh, I didn't get the question, so I didn't do it.
Yeah, I didn't publish the questions until about 15 minutes ago because I forgot to.
You can always just do the old fashioned shout out and answer.
Like it. Chaos.
Yeah.
Category ID.
Yes.
Or not, it doesn't matter to me, it's just a suggestion.
Either one. I'm fine. Well, I mean, it would take time to build up the poll thing. If somebody wants to do it, they can.
I don't know how. I can just start with some questions.
If that'll work. I'll sit over here in the corner.
So what was foreign key cheese to? Foreign
I forgot to warn
We
you.
need a category ID.
The questions are very database heavy because the material is not, but yet it expects you to know a fair amount about database stuff.
So if we don't have answers.
What's the database?
What
It's like a
type
chicken.
of database relationships have we learned now thus far? Including the preference.
1-to-1, name the name, 1-to-many.
Yep. 1-to-1, 1-to-many. And also there is single, no relationship with other objects. That's involved.
Yeah.
Can somebody describe what many to many means?
You need a junction table, you need a third table to coordinate everything.
Do you remember what the many to many example was that they gave? Or can you give an example of a many to many relationship?
Let's see, off the top of my head, I would say, let's see. No, I can't.
You didn't know I was gonna offer
Yes.
you a follow-up question. Were menus track anyone's memory? Does menu make you remember what the example was from the prep work?
Yeah, that was like there can be cheese on, one type of cheese on any number of menus.
Yeah.
And there can be multiple menus. Yeah, there are multiple menus.
Multiple menus with different sets of cheese. So maybe you have, if you're at a restaurant, you have your standard menu, your standard foods, or standard foods, cheddar, gorgonzola, and other cheese. And then you have your deluxe menu. Your deluxe menu can have items that were on the standard menu, but you also have other items. Oh. Alright. I probably would see that.
You would have seen it in the next question because it was wrong.
Well, that works out. So yeah, they gave examples of menus where one cheese can get multiple menus, one menu can have multiple cheeses. So that's a good example. And what exactly does I guess that kind of answers what many-to-many means. What does many-to-many require in terms of tables on the database?
That junction table, the third table that goes in between the two.
So it'll have one table each for just each object that's connecting, and then the junction table. And it allows us to have as many relationships as we want. How did we go about setting up the many-to-many relationship? Someone besides Phil. You're
Okay.
doing very good. How do we go about setting up the many-to-many relationship?
You have each class individually, and then you also have a joint class that with lists for the joint class in each separate class.
Yeah, so we create free models essentially, and we link them inside a special method in our DB context box. We need to do each time we change our models.
Update the data, the database table.
Yep, and how do you update them? What were some of the steps that were involved in updating?
You need to migrate it, and every time you make that change to bits and tables.
Yeah.
Database.
That's exactly right. So you update your migrations. The command for that is moving the command on the top of the Yeah, there we go. .NET, EF migrations, and then add what you're naming for that migration. And then what comes right after that. So .NET, EF database. And what is the command that's, or the bit of code that's used to determine if data that is sent via the post is correct? Are you checking the state of the model?
Model state is valid.
The model state that is valid. It's a built-in handle that tells you if your action is valid too. Okay. Did that sufficiently?
Well, it's not for me to answer.
Did that cover that? Are there any questions? Or anything that you would like Gary to cover in class? If you don't feel like shouting it out, feel free to message me directly. My Slack name is probably in Sander. And if you don't want to say it, then I'll send it to Gary. You have a question? You look puzzled. You look like you had a question.
Oh, no, I was just told.
I guess if I stand here.
What?
I don't know if I can choose text, that's fine.
Alright. All right, I guess we will get started then. If no one has any specific questions, feel free to shout them or type them. If you do have any specific questions, line for tonight, one, I'm not going to cover the studio solution because that's so you'll also be disappointed on Thursday when I don't cover the studio solution from tonight because it's the assignment. So you'll have no more studio solutions provided. You can provide them yourself because you're supposed to. After that, I plan to, and I was going to do it over there, but there's no good eraser, so I'll just have it all over my hand. To go a wee bit more in detail about all these relationships, sort of write them out, have an example picture that looks terrible, but it was the best simple picture I could find. I think it was created in 2004, which databases really haven't changed in about 20 years. So a picture that's only a little over 10 years old. But I want to cover the database concepts more than what has been covered in the material. That's what's backing everything, and each time you're doing this many-to-many setup and all this sort of nonsense you have to type into those context classes to set up the relationships so that you have them, the objects actually linking to each other. And so when you do your dbcontext.all or your dbcontext.where, and then you try to get each one of those linked relationships, what's happening there, because a lot of those methods, at least to me, are confusing if you don't know their sort of database analogous part, because it uses database terms for all of the methods definitions. So I want to cover that so it's a little bit more clear, because that material hasn't really covered it, at least not sufficiently to my liking if I were coming at this for the first time and I had no previous database experience. After I cover some of those relationships, I'm going to show some of the implementation, specifically showing a many-to-many relationship that I have set up. So the database is set up and it works. What I didn't bother to do was all the front end of combining and updating them, but the underlying table is there. It sets it up, and I'll show you the migration, which will be a little bit more clear once I cover some of the database concepts. And if you have any questions while I'm doing it, feel free to ask them. If this is your first sort of foray into databases, it can be confusing, and there's a lot hidden from you on purpose with the way that the models work in .NET, but it also sort of unhides it from you whenever you do things with that DB context, which can be confusing. So the first thing I'm going to cover, so the order of covering will be sort of the concepts between one-to-many and many-to-many relationships. I'll reiterate the one-to-many and then cover many-to-many. And then I'll show some of the implementation, and then we'll go over the specific studio for tonight, which is part 3 of the many-to-many implementation that we'll do for the MVC cheese persistent. And before I go into that, has anyone, because I'll help as we go around teaching fellows and myself afterwards, if you haven't gotten a chance to get your cheese and category relationship set up yet, we can help you with that today, because you'll need that in order to do the many-to-many later, just as a note. And this will probably fall down again, and it'll be its 3rd fall, and just break this time.
Over on this side, that you can use to tighten up the platform. It's a little higher. Right, lower, right there.
Oh, that's what you were, I'm an idiot. I was tightening the wrong one. See, it's always been tight enough to hold my music books. Oh, now it shouldn't fall. Thank you, Phil.
No turn.
All right, I'll go over to this fancy image and talk through it. Might be difficult to read. Also, it was hard to find an image that's easy to read. It's a little blurry. No, why? There we go. It's blurry. But the main reason for the image is so if anyone's watching online, they can know what I'm talking about. Which board is easier to see? More people on this side of the room. Yes. If you ever put whiteboards in spaces, you should always have a large eraser.
Forget that one.
And looks great. So the way this is set up is actually in terms that you would normally talk about tables, but also in literal terms. The idea is you have a parent and how many erase? Everyone's good with Plexpot 10,000. All right, gone. So the goal is that you have parents and parents have children. Sort of a naming convention that's not necessarily always followed Clearly .NET doesn't care about it, but generally your table names are singular. So it's each row is what makes it plural. So here we have parent and child. I told you I'd go over the one-to-many first, so that it's more clear. The way that we covered that was cheese and category. Remember from before, a cheese can only belong to one category, which is why you have two tables set up. So you have cheese, and category, where the representation, if you go and read it, that you'll see in a lot of diagrams called crow's foot notation or UML diagrams, one of the things that was mentioned earlier in the class. This crow's foot means many. So what would happen here is it's saying there's one category to many cheeses. So in our case, it was we got a hard category. Over here we have mini cheeses that belong to those categories. I don't know how to spell Gouda, so we're going to pretend that's correct. So we'd create multiple cheeses. Each one would be assigned to a category. So each cheese has a category. That's the way that we think about it from the class standpoint. So the relationship this way, the cheese has a category. You want to think about that from the object standpoint. So if we're down here, we have sort of our cheddar. So say we have a cheddar object, use the little braces to represent an object, and we go and assign it a category. What happens is that category then points over here, very specific category instance. The way the objects get set up, so I'll try to draw up top what the database looks like, what the objects look like. So if you're writing the database tables, you know that, oh, cheeses each have one category. The category can belong to many cheeses. And I keep saying belong. That is the other direction. So belongs to is another way that relationship is referenced. So if you're Googling, trying to find solutions or figure something out, the inverse of has a is generally belongs to. So the category belongs to a cheese. Now when you have objects, your cheddar, its category, then references one of the category objects over on the other side. Sort of generically, that's true of language that you're using where there's no RM, there's an abstract database underneath. Remember you have attributes on your classes, so the same is true of Python. You're using no RM there. So when we were using gful and getting all of our flip list items, we had users that had flicks. I don't know why they call them movies. But users that had flicks over here, they had many flicks. But there's only going to be one instance of the movie. So same thing for the flick list, the relationship underneath. So when you have your user and you said, oh, I want to get all their flicks, all the ones that they liked, that then ends up being an instance of the category. Or in that case, instance of the movies. So your objects are always just one level above the database table. So your cheddar points to this row. And then when you say cheddar.category, that then hops on over here and it points to that row. That's something to keep in mind. Is that all of your relationships, you need to explicitly fill those out. It won't just go and get it for you. So if you're on Cheddar, you attempt to use the category, but you never told it to go and get the category, you're not going to have anything there. You have to go and tell it, and you got to retrieve it to go and get the category. So that is the setup for the one-to-many. So that's how this is. So one-to-many, there's crow's foot notation. So if you want to Google that, read about it. Super interesting. Find one category, many cheeses. Are there any questions? Complete boredom here before I move on to the many one. Because the complete boredom is mostly true. It's probably about 60% boredom. I'm looking across. All right, now we'll move on to many. I'm gonna wash my hands after that. So this example here, yes.
One quick question, on that diagram you had, now you've erased it. Well,
Here.
wouldn't the category be the one and the cheeses be the many?
Yes.
Okay.
The reason, so that crow's foot notation I have here,
Mhm.
this is the many part of it, and this is the one. So you can also say many to one
Okay.
both ways, but because of how the crow's foot is drawn, that's what defines the relationship. And that's why those arrows, so I also have the arrow for has a and belongs to. So this is where the category was. This is where the cheese was. The direction of those arrows matters and the sort of phrasing you put on there. And that's why with the crow's foot, as it's referred to, once you get used to it, you won't necessarily need to label it one to many or many to one. So it might be easier to read many to one there. But because of the way the branches work, there's only one side that's possible to be the many. If you go and see unlabeled crow's feet, you know that the side that looks like a witch doctor talisman is on the far side. I'll keep trying to liven it up. So then over here, with the many-to-many relationship, what that's attempting to represent is the fact that you have sort of biological parents, and they may or may not have children. So we have a parent table, a child table. I'm going to scoot it over a little bit. It's a little easier to draw. We have a parent table representing a table of people who are parents. Don't think too hard on this because then you'll start thinking you should just have a table of people and it should reference back to itself. Don't think about that. Think about that you have a parent, a child, and you know you want to just define a bunch of parents who currently have children. In our world, if you are a parent, you are not a child. That's how it works here.
But all parents are children.
We'll say these are parent prime, so they're the very first parents.
Shouldn't they be child prime then?
Yes, these can be, yeah, that'll work. So these are the first parents and the first set of children. And then you'll have a table in the middle called parent-child. It's also perfectly fine because this is a many-to-many relationship to call it child-parent. The ordering of your many-to-many relationship table, which can also be called, so we'll create a table here. many of these, many of those, and many here as well. So then what you end up with is a table that has IDs, and we'll just say we only care that parents have a name. Same for children. All we care is that they have an ID and a name. And then our parent-child table will only have 2 columns. That has to be terribly small to read in the back. So it's going to have 2 columns. Parent ID. I don't have enough space, so we're going to pretend this is another column. This would be a child ID. Each one of these also, parents and children, they have names. But all you care about for your relationships, I erased my feet. If you notice, when you do the many-to-many relationship, I'm not going to wipe my hand on your sheet. I almost did, Jonathan. Okay. But I did not. Good. Wanted to. So parents and children both have IDs. Your many-to-many table, so this can be referred to as a many-to-many table, or in other frameworks and other instances, is also often referred to as your through table. Because the way that it works is you have to go through this table to get your other relationships. Because if you notice, the only thing that exists on the child table is ID. The child really has no idea that it has a parent on its own. But child table sitting there, it's an orphan, doesn't have any parents. Then the parent is sitting on its own, bored because it doesn't have anyone to watch because it has no links to the children. So the way that this relationship is expressed between the two, and it's usually implicit, so we'll draw a little space through here, is you would draw the many-to-many sort of diagram with the crow's feet on both sides between the parent table and the child table, and there's generally an assumption that you have what's often referred to as a join table. We're talking specifically in database terms. In the database terms, it will be called a join table, most often through table or many-to-many. So I'll put that in here too. Join table. Believe that is what the material called it. Join table. When you go around the Googles, many-to-many, join table, and through are also used. All mean the same thing. It's a table you use to join your 2 pieces of data together. And that's very important because if you don't have this table, and if you have what most database tables do for ID, what's called a unique constraint. So something that's been talking about is you have a primary key on a table. What that means is that's the identifier that uniquely represents that row of data. So if you're thinking about it in terms of classes, that ID is what uniquely identifies a class instance. So in our case, if we went and made a bunch of parents and we had parent 1, 2, 3, 4, say we start with 200 parents in our new world where we just started. Start out with 200 parents, each one has their own unique ID. So if you went through and you got all of them, each one of your parents is going to have an ID, somewhere between 1 to 200. And that ID is what's referred to as the primary key because it's what uniquely identifies your instance, your object instance. So think about your objects. If it were in code, you'd go and say, so C# style var, little parent equals new, parent. If we're using the DB context, you do your DB context dot parents dot find, and then you could say the ID if you knew it, or you could say where. There are lots of ways to query for it. Almost an unlimited number of ways to query for it. But essentially what you're doing when your right-hand side, so your side that's evaluating that you're then putting in your parent instance, is eventually getting filled out with one of these rows on your parent side. So it has that unique identifier, which is referred to as a primary key. Primary keys must be unique. Primary keys are a subset of what are referred to as sort of unique identifiers. You can have other columns that you require to be unique, but they may not be your primary identifier. So for instance, if you had a user table, you often will have email address on that table. And you might have ID on that table as well, so you can sort of link them together, clean up the tables. But your email address will most likely be unique. You don't want to have different users with the same email address because that makes it really hard to email them and tell them updates about your website or your product. So that's where you would use what's referred to as a unique key, which then is very similar to the primary key in that it can only have one value. But the difference is it's not the column that you use to make foreign keys. Those foreign keys are the references between two tables. So this parent ID over to your little parent-child join table, this parent ID is a foreign key to your parent table. And that's the difference. So primary key and foreign key, two things that have been mentioned in the reading. Primary key is for just one table. A foreign key is how you reference another table from within. So in that example, where you have a user table, your email address would be unique, but it wouldn't be a key of any kind. It would just be unique. And that's important because what I'm going to show you in some of the code, some of the words that they use to when you have to define them in that special method that was mentioned. I'm going to cover that. I want you to be at least vaguely aware, if you're not asleep right now, that what some of those words mean, because it will use has key, has many, and has one. And it's not clear, at least to me up front, what it's doing. So get a better idea of the sort of table structure underneath that will help. So if the other type of key, so in the code, I will use key, what's required, or set up the relationships. Right here, these are the primary keys. So the code will refer to the primary key as just key. So C# land in our ORM for entity framework, the IDs on both parent and child are what are known as keys. And the implicit assumption there is that they're primary keys. Now in our join table, in the middle, each one of the ID columns that we have are foreign keys. In foreign key, you can just think of it as an ID that is not defined within this table. It's a reference to another table. So if you have a foreign key, it must always point to a row in another table. So in our case, parent ID will foreign key to the parent primary key every time. And when you write foreign keys, generally they will always point to some other table's primary key. They don't have to technically, but usually you will always point to the foreign key, will point to the primary key of another table. It's,
Okay, on your yellow mill diagram there, would it be appropriate to have crow's feet at both ends?
yes, so the reason for the crow's feet on both ends is that a parent can have many children, and a child can have many parents.
Right.
So technically,
But I'm talking about the junction table there, there's no,
well, that's why I drew the line through the table.
oh, okay.
It was supposed to represent through the table, because generally you wouldn't, if you're showing your diagrams of relationships, you usually don't show your join tables, because there's an implicit assumption that it's there, but if you don't know that when you see a many to many, there's a join table, then you're like, I don't know what to do with these. And that's actually where I was a wee bit annoyed with the way this framework works. You have to know about this join table, and you have to actually query against it, which other frameworks do that for you, so hide it a little better. But I understand why Entity Framework does not hide it, because it does an amazing job of letting you switch between backends. When I say backends, it lets you easily switch between using Postgres, which is that little elephant I have at the top on my laptop. It's the mascot for a database called Postgres. MySQL is another database you can easily use in there. SQL Server, like 6 different versions of that. It's the database that Microsoft produces. What Entity Framework gives you is a very easy way to switch between all of those with no, from what I can tell, like unsupported feature that Entity Framework supports between the 3. Whereas other frameworks I've worked with, you will encounter features that aren't supported on all the different databases that they claim to support. So while it is annoying, you need to know about the join table. What is awesome is that once you do understand it, if you go to a different job and they use a different database than what you've previously been using, and you're using Entity Framework, you don't actually have to worry about it, because it will work.
Does any framework require the primary key to be one field? I've worked with things in the past where you have multiple fields included together in a key.
Yes, that's the other awesome part of Entity Framework, is they support what's called a composite primary key, which is actually exactly what that many-to-many table is. So I mentioned primary key is usually one. Composite primary key is multiple. So the one framework I worked with previously, Django, Python, for a very long time, it did not, it may not still, I haven't checked in the last 2 versions. If it does, it did not support composite primary keys. The composite primary keys are very useful because it's a waste on tables that you know if 2 fields make it unique together, to have to then go essentially create a third one that's just you adding them together and making it a third. And then you usually have to implement some kind of logic, is something you know to be a separator, because say if it's 2 IDs that make it unique together, you have to, if one ID is longer than the other, you don't know which one, you just jam them together. So, boring story short, Entity Framework's awesome because it supports composite primary keys. That's probably not as exciting to you now, but super exciting to me. I work with a database where all of our tables, except for 2, are defined by composite primary keys, but nothing we use supports it, so all of our queries are terrible. We don't really get to use, RM, but if we could hook up Entity Framework, it would just work. Right out of the box. That would be wonderful. But that question is a good question. Other frameworks do not support the composite primary key. And I might bore you with the data model you don't care about. But say you are a company that gets invoices from Costco and Amazon, and those invoices get paid early, so that supplier that sells 30,000 t-shirts to Costco wants to get paid early on those invoices. The way we represent those suppliers, because there will be 2,000 suppliers for Costco, the way that we uniquely identify each one of those suppliers is we say, all right, it's Costco and this ID over here. Because that ID might be different if it was, say, for Amazon. Amazon's going to have their own where they pay early. Walmart, Toys R Us, So it's very nice if you can have composite primary keys. So in our case, we would say Ooh La La Candy and Costco makes one supplier because Ooh La La Candy and Amazon might also belong there. So that's where having composite primary keys makes it very useful. If you want to learn more about that, I can tell you all about it. So back to our join table, parent-child. The other foreign key in our join table is our child ID, which foreign keys to the primary key of the child table. So if we were not using the entity framework and we're using a different framework, it is very common for there to be a third ID on your join tables, which is worthless. It'll just slap an ID on there, even though it's not needed. Because uniquely, on your join table, those two IDs together are what make it unique, makes it unique. So in our code that we've been writing with the Cheese MVC, and what I'm about to show you with users and addresses, that's my example to show you. So here with parent and child, you have a unique composite primary key. Unique's redundant, in fact, it's a primary key. But that may not be obvious if you have to work with the database. If you have a primary key, it has to be unique, because if you go to query and it returns more than one, that's not what's supposed to happen when you query for a primary key. Sort of like when you yell at your kid because they've done something wrong, while most of the kids will likely turn around. You really only want to yell at one, the one to get one. So same with the primary key, you really only want one. So when you have the composite primary key, what that says is there can only be one. If I have parent 2, and we're saying, all right, parent 2 is the parent of child 4 over here. The way that we set that up is we have, for parent ID, we set up 2, and then for child ID, we set up 4 as one of our rows in that table. In the join table, there is no, like 2 and 4 in there again doesn't help, because we've already established that child 4, that child over here 4, is the child of parent 2. So we'll say Jill, Frank. So if Jill is the parent of Frank, we only want to and need to establish that relationship one time, which is why you have the composite primary key of parent ID and child ID in your join table. And that will be the case in any join table. Your 2 foreign keys together make a composite primary key. Because you want to only define that relationship one time. If, for some reason, you wanted to like keep track of how many times you define that relationship, that is where you would set up another table to just keep track of counts. Because your many-to-many tables should not contain bonus information. But you might be tempted to throw like a count column in there, and then each time you go to define it, just increment that count. Don't do that. Because you won't care now, you probably won't ever care. But if you want to look into why that's not necessarily a good design for your data, you can look into what's referred to as database normalization. It's not a very fun read, but you can read about all the different forms of it in probably about an hour. And then over the course of probably like 15 years, which I've not reached in writing code, understand it. But there's a good article that was written in 1994 or 1996 that I can link to. That's right, database has not changed in 20 years. Relational databases are under the covers, all based on something called mathematical set theory. If you really want to learn more about it, you don't, so don't look at that. What you care about here is how to define your many-to-many relationships. And if you want to know more about why your join table should not contain more than the 2 foreign keys. You can read all about database normalization. The only reason I mention it is so if you want to learn more, you have the fancy words to go and look it up. I actually had to reread about it the other day because it's the first time I've had to go and create a bunch of new tables at work in a long time. Are there any questions on the many-to-many relationship before I show some of the C# entity framework specific ways to achieve many-to-many? You can post them in Slack. You can just ask a little bit. If you don't want to ask, that's all right. My laptop didn't fall, so that's good. It's only mildly damaged from Thursday's fall. Now it creaks whenever I open it. Wait, where'd my code go? All right. So hopefully this is readable. I haven't opened any of the code yet. So sort of the general layout, you'll see, and this is what it generates for you when you do the .NET Lottie Bloop, generate a new project, business. It will create a data folder. That data folder is what contains how you get to the database in C#, the DB context. If it wasn't clear, I've moved on to the C# example portion, away from the theory of databases. And then you have your models defined in your models folder. Then you go and put them all into your DB context. So in this case, sort of make it, I'll pull the models up first. And I'm doing this actually as, oh, yay, no. So something that is very common when you create database tables, I've mentioned this in the past, is to have created and updated dates for every record in your table. It's also common, but I didn't want to deal with it here yet, to also put created by and updated by fields. So when you have a database and you have records, what you want to know when it was created, and you want to know when it was updated. The reason for that, so like in Facebook, whenever you're seeing your news feed, or if you're on Twitter, or if you're reading an article on the Washington Post, or any other news site, the Times, New York Times, Time Magazine, when I said Times, that's what I was referring to. Or People, if you prefer that for your news sources. Created and updated. Created will be when they initially wrote the article. Updated, you would want to see, because if they have a factual retraction or something else to go and update, you would want to know that an article that was published 8 months ago has now had updates. And if you don't store created and updated, then you don't know when that happened. So it's very difficult to display to your users, oh, this is when it was last updated. Or say you're wanting to go, I think it's allrecipes.com, and you're wanting to go and check out the latest recipes that have been updated or people have voted on. You can sort by newest recipe, which is when people put them in there, or you can sort by updated most recently, and then you can see sort of what recipes have been changing. So that's an example of why you would want a created and updated date separately. And whenever you represent your tables with classes, often you'll create what I've referred to here as a base model. With all those fields you want all of your classes to always have. So in this case, we always want created and updated to exist, and we always want them filled out.
Can you put a primary key there too?
So the question was, would you put a primary key there as well? I would not put a primary key. I would put what is often referred to as an index. So something that hasn't been covered for the databases, there are things referred to as indexes. The reason you use an index is if you're often going to order or filter. So on a website, say you're shopping on Amazon and you filter by a category, under the covers, if Amazon is storing that data in a table, they have what's referred to as an index on that category. And that's so that it can quickly, the database can quickly go, oh, I'll grab everything with that category. Because if it wasn't indexed, so that index term, what happens is it has to go through every single row in their table. And their category table likely lists millions of categories because they have categories for everything. So then if you have millions of rows in a table and you don't have what are called indexes, whenever you go to query it, it will be very slow and take a very long time to return your query. So if you're ever noticing as you start to add data to a website or to a product you're working on and it gets slower and slower, at that point you will likely want to go and look, depending on which database you're using, sort of ask it, why is this query slow? And it might recommend an index to add. So that's often referred to as an explain plan or an explain query. Depending on the database you use, that's kind of the term. But so Phil mentioned, whole reason I've done this, adding a primary key for created or updated. What you would really do is an index. And all an index does is make it faster to go and find the data for the database. It's like sort of creating a short list of just those items. A small caveat there, you don't index every column in a table because at that point you will have made your database super slow to put data into. So with the base model, the reason this is created is so that the reason I made this, I try not to overload terms because I have created on there. The reason I made this base model is so each subclass, so in this case, I will have two subclasses, a user class and an address class. So you can think in a software system, you're gonna have many users and there will be many addresses. It's very possible for multiple of your users to belong to the same address and for one address to belong to multiple users. It's a good candidate for many to many. You can think about you and your coworkers all work at the same location. If you work, say, in this building, but then people that are not your coworkers also work in this building. Where'd my cursor go? So then for the user, and I even put an email address on here to show another example of using a primary, not a primary, a unique column, which does create an index underneath. But I'll show that when I show the context. So our user class inherits from base model. And the user has an ID, has a full name, and an email address. For fun, and because I don't like to show bad examples, both the user and the address classes, you may want there to be more in them. When it comes to names and what's referred to as globalization or internationalization, you really just want full name. And potentially nickname or desired name, because in many different places across the world, the number of names someone has can range anywhere from like 1 to 7, being first names, middle names, last names, all depending on how their culture recognizes names. That's why a lot of software systems that were initially made in the US and then just like got ported over, that don't work out in Europe, Middle East, Asia, because not everyone just has a first, middle, and last name. Which is why, if you have the opportunity to create a user table, you should just do full name, and that'll be it. And then potentially nickname if they have a name they want to have displayed. It does make it more cumbersome if you're trying to do any type of analytics on your data, sort of like data sciencey stuff where you want to see like, oh, these are all the last names. But you can also do just a little bit extra work to sort of split that out however you want to. Then email address, because likely your users will have email addresses. If I were doing this correctly, I would have created another table called email address, because users could have multiple email addresses, but I didn't want to go through all creating like 6 different classes. So in our world, a user will have a single email address, and that's all they're allowed to have. They can't have more than one. Fun fact, that's the mistake that they made where I work. So if you're a C2FO customer, you can only have one email address. It's also your only way of logging in. So if you change your email address, that's too bad. And then, as you might expect, we have a join table between our users and our addresses. And for the case of C#, we join those together with an attribute, property, sorry, C# calls them properties, so that we can reference them whenever we try to query. Note that the only part of your model that makes it into the database, you go to create your definitions, are the things that are what are called primitive types. So things like integers, strings, date times, technically not primitive, but sort of those built-in types to C#. This iCollection addresses user, that doesn't actually do anything at all. If you go and define your DB set and you say user, and that's there, yeah, it doesn't care. It just ignores it when it goes to create that relationship schema. Because the only types of data that it looks at are those sort of concrete types of integer, string, date time, float, decimal. And you probably don't care about the differences between float and decimal. But they are different. Double, sorry, it's double and decimal in C#, float in other places. So to show the address class, no. Now you find out my keyboard shortcut is Command B to close that tab. So address. That says dates. That means addresses. That's nonsense. Address class inherits from the base model so that we know when we've added an address or updated an address for the user. And again, those created and updated are actually very helpful. So if someone calls in to whatever you're working on and they're like, hey, I never did that. Well, if you store updated and updated by, you can actually tell them, yes, you did. You actually updated it an hour ago when you logged in. They go, oh yeah, you're right. People don't intend to lie. They just may forget. They just forget that they did it. So it's very helpful when you have users you want to not sort of just like leave out there. Makes it easier on you as the developer and or the support person to know when data in your system is updated and who updated it. So if you can have updated dates and updated by on each one of your rows, you can know who did it. So for our address model, it will have an updated and created date automatically because those are defined on our base model. So created and updated are there on the base model. It has an ID. And this might seem crazy that the only thing I have for the address is value and country. But much like I mentioned for the user, addresses are terrible across different regions of the world. So what you would actually do, and using this as you would sort of build out your system, the reason country is there, you might go as far to say country and it starts with a P. It's province or postal code. I believe those are fairly uniform. The reason you might use both of those is so that you can display to the user a nicer looking form for them to fill out. So if they specify they're in the US, you give them that nice multi-line form, and then you can just go and save it using your own validation logic into the database. And you can set up your own view models for each type of address that you're going to save. And that's another example. I was really excited about view models earlier. I wasn't able to give you really good concrete cases of why I was so excited. But one of the things that's sort of awesome about them is, in this address example, you know, I think there's something like 70 different ways for addresses to be formatted and saved across various different regions in the world. If you can go and define probably the 20 most common view models for that, it makes it way easier to go, oh, they're from India. So in this case, we're going to use this view model to validate that their address matches what it should. So that is an example of where it can make it a lot easier. So your view model, that's specific to say, because we're probably more familiar with US addresses, we'd create a view model for the US address that would say, take street 1, street 2, apartment number, zip code, city, state, and then that would allow you potentially the zip code extension, the extra 4 or 5 you can throw on the end. But you can display that form to the user, and you can validate it very specifically to a US address. If it's valid, you just go and save it into your value field. And because at that point, you've already formatted it, so your new lines that you would do to have sort of the 3 or 4 line address, you can store that. And then you know what's in your database is exactly how you want it to be perceived or seen by the user. And because you define the view model, when you go to get that data out, you have a way to represent it with your view model. So that's the idea, that a view model does not have to, a model is not necessarily one-to-one with a view model. It could be one-to-many with view models from an object standpoint. So in this case, we have one address table, but it could have a whole bunch of different view models to represent it. But more specifically to what we're covering, the many-to-many relationship that we're going to set up here are users to addresses and addresses to users, because there can be many-to-many back and forth. Our address, all it has is an ID, a value that represents the value of the address. So basically everything except for the country. And then country on there so that we know where it should be. And then finally, much like the user, it has an iCollection, so an interface of address user, so that you can reference it whenever you're trying to do your query lookups. So then finally, showing the join object or join table. Address user could have been called user address. Order doesn't matter. Has a user ID and an address ID. And then for the sake of entity framework and making object references easier, it has the user defined on there and the address defined on there. If you notice sort of what looks different here from the diagram that we drew is because we need those object references back and forth for it to be easier and so that the entity framework knows our relationships. And this is where you get the many portion. We know that our address has many address users because it's a collection. It's a list of them. And then we know our user has many address users. And because both of them have many of that one in the middle, and the one in the middle only has one of each, that's how we get the many-to-many relationship between our models. So now we've defined our models to be able to support a many-to-many relationship. And if you're like me, you wanted to stop here and have it work, but it doesn't. I wanted it to work here, and it did
You're
not.
not alone.
So now we've defined our 3 models, 2 being the users and addresses, and then we've defined that join model in the middle, the address user model. And before we hop into the database context, you must make sure in your configure services in your startup file, so you have your startup.cs, if you're wondering why your database doesn't exist or it's not doing anything, you can't find it, make sure that you have a definition in your configure services that says services.addDB context, the type of your database that you've explicitly defined, and then whichever database backend you're using. So on the Mac, I have to use a database that's called SQLite. If you're building a real website you want people to use, don't use SQLite because it's a very small sort of file database. It is fine for very small websites. Say if you just had a blog, it would be totally fine for that. The reason you don't use it in .NET is it doesn't support correctly, and they mention this in their documentation, all of those unique indexes. So whenever I mentioned email had to be unique, the database will do nothing for you with the way that Entity Framework and SQLite go together to actually validate that that is correct. That when you go to add a new user, that the email is unique. If you use any of the other databases that Entity Framework offers you, they all do that correctly. So if you're using SQL Server, which seems to be a pretty popular one to use with Entity Framework, it will work. MySQL also is fairly popular, one I've been able to surmise. So MySQL is another option that you can use. And the way you set that up is you just do your options.use and then certainly whatever the database name is. You have to make sure you have that specific one installed. So if you use that NuGet package manager, you can go to the NuGet package manager specific to your solution. So you can right click on your window and solution finder, and you can say NuGet package manager. It'll open it up, and then you can search for Entity Framework and then whichever database you want to use. So MySQL, and there will usually be something like Microsoft.EntityFrameworkCore.MySQL as the option to use. SQL Server is another one that you can use. There's SQL Server Community Edition that you can use, but that one's not officially supported by Microsoft. But as I mentioned, there are a load of SQL Server options if you want to use them. The key is to make sure in your configure services method in that startup, you've told it which database to use and you are passing in some way for it to connect to a database. So the sort of default that kind of vomits out for you when you make a project that is made for you, you have this configuration object, .get connection string, and then default connection. So that connection thing comes sort of magically from .NET land. It's already imported in this file when you go to use it after you've created something. And that default connection, if you are curious, is in your app settings.json file. Depending on which version of .NET you're using, it's in an app settings.json file, or it is in your .csproj file, depending. It can be in either one. But what matters here is that this sort of default connection is referred to as a connection string. It's what tells Entity Framework how to find your database. If you don't have something filled out, it won't know how to find your database. So something needs to be there. Generally, if you're using what's built in, it will sort of just like make one there in the folder for you, which is fine. Whenever you're first starting out, when you go to do your project, you'll want to have a little bit more control over the database so that, say, you go and deploy your code out to some cloud hosting provider and you decide to switch. You don't want to lose all of your data because you switched cloud hosts. You want to be able to define your connection string that just points at where your database is, sort of wherever your database may be. And if you're ever having any sort of problems, like it complains about cannot find bloody blue designer or something else, look in your project file or what it may be packages, config file. Make sure that it's somewhere in there you have an entity framework and then whatever your database that you're trying to use is there. This file should automatically get updated for you when you say install SQLite or install MySQL. When you tell it to install one of those databases, this file should get updated. But that's somewhere to look if everything seems like it should be working and it's not. Just take a glance at this file to ensure the database type you're attempting to use is actually in here. Because that database type being in this file is why that, combined with the import that's happening at the top of the file, is why I can do this options that use SQLite. If I didn't have SQLite defined in that project file, this method doesn't exist. And I go into this detail because I had all of these problems and I was trying to set this up. So I imagine maybe it's just me. I may not be good with .NET and setting up the database, but all those little pieces, I encountered each one of those because I'm not following necessarily exactly what Chris has. But when you go to do your project, you're definitely not going to be following and writing Cheese MVC 2.0. You'll likely be writing your own project, so having a better feel and idea for how to make sure you have each piece in place will hopefully be helpful. So we've talked about the defining of our three models: user address, the join between the two, address user, and then making sure that within our startup, we've hooked up our database context. I haven't shown you the database context yet because I want to talk a little bit through how that's setting up. And then making sure that the database we want to use is defined in your project configuration. So in this case, you can see that there's a .SQLite in here, and that's what makes that work. I attempted to use the SQL Server because I thought that it doesn't. It does not work. So if you're on the Mac and you attempt to use SQL Server, you get a really ugly runtime exception.
How rude.
Yeah, it complains, and then I complained. My wife didn't understand while we were driving to St. Louis why I was complaining in the passenger seat. Database context didn't mean anything to her. So, as you probably wondered, now we go and define our database context. So I call it user address, DB context, because that's what I named the project. So usually your database context will likely be named after your project, and then DB context. Sort of the convention I've seen so far. It may be completely wrong, and I've just seen all bad examples. That does happen. I had bad practices for the first 3 years of writing code in Python because I just happened to see a bunch of bad Python code. I blame my teammates.
Not your fault.
So this DB context, as we've seen in the past, we set up the relationship, what I refer to as the single relationship, but it's sort of the not related to any other tables, because as you sort of saw in our parent-child, there's no columns in there that indicate that it's related to anything else. So all we do is we say we want a users table and we want an addresses table. And then there's very specific constructor overloading you must do. And specifically say that your constructor takes the DB context options, your type. Remember when we did this setup and startup? And we pass in the options, and it's a DB context options builder. Well, what ends up happening within the framework is the builder, as you might expect, ends up building a DB context options of type user address DB context. That's important because if you don't have alignment between your constructor here and what you've defined here in your startup.cs file, nothing will work, and the errors you will see are terrible. They're not helpful. So if your database context just seems to be not working at all, and you're not getting anything, and it's always null, you're not getting really any errors, but you're not getting any information, and you can't really write code because it keeps complaining that things aren't accessible, make sure that you've overridden the default constructor here that takes your DB context type into account. And then you pass the options along to that base constructor. And you need to do that in order for it to sort of do the magic of connecting all of the .NET MVC portions together. This constructor is very important, and if it's not set up exactly right, it won't work. Fortunately, it's only one line, and you can pretty much look at any example you've done previously and just exchange out this type for whatever your new context name is, and it should work. But do make sure you have that. Otherwise, it won't work at all. Now the fun part where we go and define the relationships. So this is one of the sort of weird cases where you're overriding a protected method. So we talked about the different access modifiers that objects have. So the superclass here, the DB context, has a protected method, which means that class and only its children have access to this method, which in this case is the onModel creating. Now, what's not immediately clear is why when you override this method, all your database stuff happens to work. The only reason you really know that, or even I know that, is because Chris put it in the example. But if you go through and you read a bunch of stuff about Entity Framework, it explicitly tells you, oh, if you create your own database context, which you're required to do if you're going to have a database, there are a few, I think there are 4 or 5 methods you can override to get different behavior. So in our case, we must, because we're using .NET Core. So Entity Framework Core. Make sure if you're Googling and you're writing Entity and you're writing .NET Core code, you're only finding solutions for Entity Framework Core and not Entity Framework 6. Fun fact, I get to write code for both right now. It's very confusing. It's confusing because all of what is defined in here, if you're looking at older versions of Entity Framework, is not defined in here. It gets defined elsewhere, and it has a higher amount of coupling between your models and the way that Entity Framework consumes those models. So the direction they've chosen to go with Entity Framework Core is that all of your database setup happens here in this file. So if you think about those models and the classes that we define, so we have user and addresses. We've only set up those models so that it's easy to reference the objects in the system between each other, so that I could go and type out so if at some point I wanted to have a new user, I could go and say user.address_users . Oh. So that once I have an object that's defined, now address users, what we would normally do is we'd have somewhere where these users are already at, and then I could say user.address users. I might do a for each and then here, I would then be able to go and reference the address. So I could go and do something with that address. It's complaining because it knows that address isn't initialized because I'm not getting it from anything dynamic. But all we've done is set up those models. And the reason I bring it up is Entity Framework Core, which is what you need to make sure you're looking at when you look at any examples for the relationships and how to set them up. There is not a lot of information on Entity Framework Core and setting up the relationships currently because it is very new. So you'll see hundreds of blog posts for Entity Framework 6, 5, 4, all the way back. You'll see hundreds of those, and it looks like it should just work. And it does if you're using an older version. So make sure when you're looking at either the documentation or someone's blog post, make sure it's referencing Entity Framework Core because it works differently. And the main part of that is they've separated the use of your models completely from the Entity Framework. So your models, as we've defined them, in our case we have user. This is a plain C# class. There's nothing in here at all that references anything about the Entity Framework. Same for all of our other classes and that join class, the address user. Nothing references the Entity Framework, and that is on purpose, and it's a choice that Entity Framework Core has made. But that puts extra work on you so that you have to define all the relationships in this on-model creating method, which you may not appreciate now that you have to go and define all of these in one spot, and it's kind of verbose and tedious. You only really do this once, so it's not that bad. And it gives you a lot more freedom and ease of use for those models. So when you're writing tests, you don't have to do anything special to those classes. So if you're, the reason I bring that up is if you find examples for Entity Framework 6, where we have this has key and all that, you'll see examples where what happens is we'll see examples that do this. It's sort of like apply filters as we've seen in controllers. If you see an example that looks like this, it's not for Entity Framework Core. So if you see that, you can likely assume it's not going to work. And that's not exactly syntactically correct. But you'll see something like this, sort of decorating method if you sort of look for examples. If you're like, oh, I want to make my email addresses unique. That's the first thing you'll see, at least if your Google results are anything like mine. But that's not what you need to use to make something unique using Entity Framework Core. The advantage now in having this user class not have that, when you go to write tests, you don't have to do anything special to validate email addresses work how you want them to. when you have all those fancy filters and decorators on your classes, it makes writing tests harder because you have to do more work to be able to use that class. Because it's not just a simple class at that point. It's gone and had some junk injected into it because of those filters. So now what you then end up having to do over here, and it's a wee bit tedious, but not terrible. And this is why I kept talking about primary keys versus foreign keys, is for the data that we have for hours. So I'll just go and hide. First, we define our, so this model builder gets passed in automatically into this on model creating. So that's the protected method we're overriding. That's why the override is there. Void, because it returns nothing. And you end up getting this model builder class that has goodies on it. That is what makes it all easy-ish to hook together. So what we go and do to set up each one of those relationships, so set up each table and then the relationships between those tables, first thing we have to do is go and define each one of the tables that is going to exist. So in this case, we go and say, all right, model builder.entity user has this key ID. So has key, that defines the primary key. So sort of you mentioned it, can be used to configure the primary key. What, and the reason I kept mentioning primary key and foreign key is all the documentation I saw for all of this configuration refers to everything in the database terms. So if you're not familiar with those terms, it makes it pretty annoying when you're trying to go and write any of the code. At least it was annoying to me thinking about when I knew nothing about a database, which was when I started at Cerner. And then I saw things that were like, oh, it's just primary keys and composite keys and indexes. Like, I don't know what any of that means. You're not helping me. I know what a class looks like. So that's why I kept reiterating primary key, unique identifier of a table. Foreign key is how one table references another. And due to sort of how databases work, we need to define our tables first before we can define references between them. So if you think about that, we need to create our user and address tables sort of here in memory to define that they're going to exist, and also define our join table, so address user. And this is where that composite key part comes in. You can define multiple keys in order to create that composite primary key. So continue ignoring here. So user has key, and then it uses that lambda expression. Seems to be very common in all things related to this database context. Essentially, everything uses a lambda expression. All that is an anonymous function, or a function that is not named somewhere. So what this u fat arrow u.id means, I could have been less terse about it, and probably should be, is that has key takes a function, and it passes one object into it, and then it will return that user.id from the function that's getting passed in. That's what all that shorthand syntax refers to. You'll get more used to that the more that you write code and the more that you sort of do work with Entity Framework, and more that you do work in C# and have more experience with a lot of these sort of framework level definitions of objects. So when you try to go and do querying with LINQ, you have to do very similar syntax, you know, the where clauses where you say where user fat arrow user.id equals query parameter that was passed in ID. That same idea is what is happening here. You're just saying, oh, I want the user ID to be the primary key. Same with address. We have our variable that I gave a very terrible name with just A. The only reason I've sort of given the bad variable names is it seems to be fairly common practice whenever it is a Lambda expression that does one thing, and especially in these table definitions, to do the sort of abbreviation for whatever your type is. So that's why I did A, short for address, U, short for user. Then the same for address user, not Australia, as you might have thought. As key, and then I go and use this sort of shorthand object literal syntax. So as you can tell, it creates an anonymous type that the Unity framework goes and inspects and figures out that you want to have a composite primary key. So much like our example over here with parent and child, where we have parent ID and child ID that made up the uniqueness of each row. For our addresses, the uniqueness will be user ID and address ID. And that will be uniquely identifies for that object. And then finally, how we go and relate the two together is we say our user has many address users. And the same, our address has many address users. So in some of the examples that Chris has, there was a lot of what's referred to as chaining. So it was like dot has min, dot has key, dot many. They just kind of kept chaining it together. You can't necessarily always do that. So that's why in this case I can't, because that has key does not. The reason that works, that chaining, is because each one of those methods goes and returns the same object each time it's called. So internally what's happening is it's just returning itself each time. So it would be the same as if we went in here and we defined a method that was, we say that it returns a user. That's what each one of those methods is doing internally. They're just returning the object that you just called. So if we did user.do something, we could keep doing that over and over. And if you kind of want to see that, over here, I could do .do something, .do something, and I could just keep doing that because it keeps returning a user each time. That's the reason that that sort of method chaining works, is because each one of those methods returns the object itself. So it's not as magical as it may first appear. And this setup here will create the database schema you need underneath to go and have a many-to-many relationship. That's not what I wanted. Then over here in your controller, this is the last part. You need to make sure that your constructor for your controller. I don't want to give away all of it, so I don't have an example of doing the querying yet because that's
Oh, come on, Gary.
part of the studio. Your constructor, make sure you override that to take in the type of your database context so that you can use it in each one of your methods. So you can go and query the database. Or if you wanted to be really logic split about it, you could pass your DB context to your view model and let your view model use it to go into the data. That's up to you. You could go about it like that if you wanted. Not required. Any questions for studio time? Yes.
So in the old ASP.NET, you had to like say open DB connections, and then you like write whatever code you want to do in your database, and then you had to close it. So does the data layer or the data model or whatever like make it so that you don't have to do that anymore?
Are you talking about, so you're talking about using the database directly? As in you're writing the code to connect to it and disconnect from it?
Yeah.
Yes, so that's the part where Entity Framework with MVC does the work for you of opening and closing the database connection.
Okay.
It handles that. If you're not aware of what a database connection is, in most any website or server that you set up, draw on the other board. Say this is Facebook, and you're over here on your laptop. You go and request the all cats page, cats news. So you go to Facebook, you request cats news. What normally happens, and what happens in Entity Framework, but it does it for you, is when you go and make that request, it hits the Facebook web server. Facebook web server then goes and opens a connection to the database, gets the data out of it, and then closes that connection. Entity Framework does all of that for you, but in case you weren't, if database connection, opening, closing, that didn't make sense, that's what that's referring to. Entity Framework takes care of it for you. So you don't need to worry about it currently with the code that we're writing because it handles all of the logic here for you. One of the other advantages of using Entity Framework is it takes care of that on your behalf. You don't have to worry about it as much. So there's a question in Hello KC around signing up for the checkpoint. If you are having trouble signing up for a checkpoint, Catherine will know how to guide you through that if it's not working when you go there to sign up. Unfortunately, I have no access to that. Or fortunately, depending on how you view it. You might think I'm too strict. So I'll cover real quick what the studio is for. So hopefully everyone got the one-to-many set up with the category and the cheeses. Talked about that earlier as well. If you did not, we are happy to help. You're also welcome to work in groups still. Not just welcome, encouraged. Find a buddy. Think of Buzz Lightyear and Woody. They're good friends. If you don't like, I don't remember who Ed the horse. Peanut butter, that's really all I can remember that he had. That's what they used in his mouth to make him talk. So the goal here is to set up menu and cheese menus. You can cheat and technically just copy the code that Chris was writing, but don't do that. Try to do it from reading the instructions here and reading some of the documentation and Googling. The goal is to set up menu and cheese menu. And I will mention you need to update the DB context, sort of had, just like I did, the relationship setup that has key. And then you'll want to update all the list views so that you can show cheeses on the menu. You want to be able to add the menus. It's a lot to take in, which is why it's both the studio and the assignment. Oh, he didn't give you that nice little, he did tell you what to test,
Well, sanity check.
but he didn't give you the nice little sanity check section that says these are the 4 things you should have done. But what you want to do is implement your many-to-many relationship so you can have as many cheeses as you want on as many menus as you want, and vice versa. You want as many menus as possible to have as many of those cheeses. Just like our users can have many of those addresses, and that address can belong to many different users. Or in the case of parent-child, parent can have a lot of children, children can have a lot of parents in our model. There's more than 2. As many parents as you want. Any questions on this before you get started? Because you are free to get started now. Are there any other questions that people think would be good to cover overall before we break? Work on the studio. You're welcome to stay in here. Go next door, 1 room over. If it's too cold in here, you can adjust the thermostat. I don't really care. If it's too warm or too cold, you can also go in the other room and set the thermostat to your perfect level.